Today, we're talking about something pretty cool: how AI is completely changing the game when it comes to software reliability. We're going to explore how you can find and fix system failures before they turn into one of those catastrophic, all hands on deck outages.
So let's just jump right in with a big question, especially for all you developers and SREs listening. What if that dreaded 2 a.m. alert, the one that tells you production is on fire, what if that was something you could actually prevent instead of just reacting to?
Because let's be real, in the incredibly complex systems we're all building these days, failures aren't really a matter of if anymore, are they? They're a matter of when. It's a problem every single one of us in tech has to deal with. Oh yeah, you know exactly the one I'm talking about. The one that yanks you out of bed and throws you into a frantic debugging session, all while the customer impact is just ticking up minute by minute. That stress, that pressure, that is exactly why we need a better way to do things. For a while now, the best practice we've had for this is a concept called chaos engineering. And honestly, the easiest way to think about it is like a fire drill, but for your software. The whole idea is actually pretty simple. Instead of just waiting for a real fire to break out, you practice for it. You deliberately and safely introduce small failures into your system. You know, things like a little network lag or a service timing out, just to see how it holds up. You're actually proving your resilience instead of just crossing your fingers and hoping for it. And this right here, this really nails the fundamental shift in thinking. We're moving away from this reactive posture, where we're basically just sitting around waiting for things to break. Instead, we're becoming proactive. We stop hoping for the best, and we start proving our systems can handle the worst. But here's the catch. As our systems have gotten just ridiculously complex with all the microservices and cloud infrastructure, just running these manual fire drills isn't really enough anymore. There are just way too many things that could go wrong. And that is where AI steps in and completely changes the game. This visual just captures the problem perfectly. A human expert, no matter how brilliant they are, can only really predict and test a tiny, tiny fraction of what could possibly go wrong. We're talking maybe 5 to 10% of the potential failure scenarios. That leaves a massive 90% blind spot. So, how does AI solve this? Well, first, it dives in and analyzes your entire system architecture. It learns every single service dependency, every timeout, every retry logic. Then, it uses all that knowledge to find the fragile paths. Those are the sneaky spots where one tiny failure, like a slow database query, could set off a catastrophic chain reaction across your whole system. And, crucially, it then prioritizes the experiments for you, targeting the biggest, most dangerous weaknesses first. Now, this isn't just some theoretical improvement. The results you get from this are concrete, they're measurable, and frankly, they're often pretty dramatic. This is the part that turns a smart idea into something you really have to have. I mean, this quote just says it all, doesn't it? You don't have to wait months to see a payoff here. Teams that use this AI approach are finding critical, ticking time bomb vulnerabilities, the exact kind that caused those 2 a.m. outages, in their first handful of experiments. These are issues that were just hiding there, completely unnoticed for who knows how long. And if you want hard numbers, here they are. By finding and fixing these problems proactively, teams are seeing a 60 to 70% reduction in production incidents. I mean, just think about that. That's cutting the amount of time you spend firefighting by more than half. So, what happens when an incident does manage to slip through? Well, because your team has basically practiced for this exact scenario, they're way faster at fixing it. Mean time to recovery, a supercritical metric for any ops team, drops by a solid 35 to 45%. And just look at the impact on your team's most valuable resource, their time. With a 40 to 50% reduction in incident response, just imagine what your developers could build with all that time to get back. It's a huge deal. Okay, so this all sounds great, but I know what you're probably thinking. The big question is always about safety and how to actually implement this. How do you do this without creating the exact problems you're trying to prevent? This is always the number one concern, and it's a totally valid one. If we're going around deliberately breaking things, how in the world do we make sure we don't accidentally break things for our actual users? And the answer is a very clear and absolute no. This is the most important rule. Proper chaos engineering is always done in a controlled, non-production environment, like a staging or a testing server. The scope is carefully contained to make sure there is absolutely zero impact on real customers. Safety first, always. So, let's just end with this thought. Right now, when it comes to your system's ability to handle failure, are you operating on hope? Or have you actually proven it with hard evidence? AI chaos engineering offers a clear path to get from one to the other.